Welcome to Astronomy Live. Tonight, doing some deep space webcasting here. The ST2000XCM is imaging in infrared right now off my wide field refractor. And we're pointing somewhere in the constellation Sagittarius. It's nice to finally be up and running again. Had some issues with weather the last few nights. And still not ideal. Occasionally we get clouds coming through, and I do occasionally see flashes of lightning off in the distance, but check of the radar shows that they're pretty far away. So I'm not terribly concerned about getting rained on any time in the immediate future, knock on wood. But clouds are a definite possibility. But it's the best night I've seen for a while, so I'm going for it. Now, tonight's objective is going to be a general search through the constellations of Sagittarius and Capricornus, and we're going to be looking in the location that Gill Broussard's planet 7X would be in. Recently I heard about this guy, and actually heard him interviewed on a show, John B. Wells' Caravan. What's his show called? Caravan to Midnight or something? John B. Wells, if you don't know, he was a guest host on Coast to Coast AM, and he's got his own internet radio show. And it might be actually syndicated on some stations, I don't know. I just know of it through the internet, through the interwebs. And Gill was presenting his alleged research and his book, which is freely available for download online. And he's talking about this planet he thinks is out there for biblical reasons as well as scientific reasons. Ooh, what a beautiful picture. Oh, I love this camera. Oh, let's not do auto dark. Hey, that would make me happy. Uh-oh. Okay, good. Auto guider's still running smooth. We're not going to do auto darks tonight. Oh, it's so beautiful. So many stars. And as I said, I think I mentioned this, the camera is imaging in infrared, so I'm blocking all visible light, only allowing infrared through. Now, Gill didn't make the claim that his planet's only visible in infrared. Some people try to do that because they think that will hide it. I think that'll make it impossible for amateur astronomers like me to possibly see it, but that's not categorically true. As a matter of fact, telescopes like this one and cameras like this one are infrared sensitive and can image the stars in infrared. Everything you're seeing here, all these stars right now, are being recorded in infrared light. So, okie dokie. That's running. Now, I am going to have to pop up another window here, and it's going to block your view. I apologize. I'm not going to show this other window because it shows my exact location on Earth, and I don't want that information being public. Sorry. So, bear with me as I switch fields. So that was the first field of view, and I've recorded that image, and that image is saved to my hard drive, so we can analyze that later. What we're going to do is we're going to do a panorama here across a wide section of sky, and I'll show you in a minute how I determine where I'm going to be pointing. Hey, that's not the right file. Where's the right file? That's not it either. Somewhere here. Oh, come on, where did it go? Really? It's gone? Oh, it's on another window. Here we go. I've got a window here of a list of coordinates that we're going to be pointing at. So I've got the telescope hooked up to the computer, and I'm just entering the coordinates in the computer, and that'll feed it to the telescope. Should save me some time rather than getting up and entering the coordinates on the hand controller every single time, because we're going to be doing this every 5 minutes, switching position. And then say It's not really what I want. That's close enough. Just trying to get it pretty well aligned there. All right. Now we do image 2. First, we set up the auto guider. Fortunately, it's a target-rich field, so there's generally going to be a guide star pretty quickly available, I hope. There we go. Starts guiding, and we start imaging. All right. So, let me show you, if I can do this carefully, how we come to pointing at these coordinates. Pull up, sorry, I've got to pull up Google Hangouts here and switch the mode in which it's screen sharing. So I've got to toggle the screen sharing to full screen somehow. Okay, Hall of Mirrors, sorry. Now, that should work, yep. So here is a figure from Gill's book that shows the hypothetical orbit of his planet, projected orbit of his planet. And he also gave in the book information about its orbital period as being 319 years on this orbit, and that the perihelion would occur in February of 2016. In fact, he gave a specific date. I think it was the 17th, but I'm just going off the top of my head here. I could be wrong about that, but whatever the date was, point is, he gave that date. So that gives us a fixed point in time of where perihelion should occur and how long the orbital period is, which tells us the semi-major axis. The semi-major axis is directly dependent upon the orbital period and vice versa. Now, what he's showing here in this figure is the orbit of his planet relative to the inner planets, and what he probably didn't realize is that he's actually giving away everything you need to know to directly calculate his orbit, to actually reverse engineer it effectively. He also gave the inclination as being a very small figure, about 0.02 degrees, somewhere in that ballpark. So with a top-down perspective of the solar system like this, we can figure out exactly what this orbit is supposed to be. And if you know a little bit about orbital elements, that might not seem possible just by seeing a line going through a bunch of other lines of the planets, right? You need very specific longitudes, longitude of perihelion, of the ascending nodes, and all of that. But this figure actually contains that information. He's using Starry Night to create this figure, and Starry Night embeds that information in the lines. These little pips right here, these indicate the longitude of perihelion. And we know the longitude of perihelion of Mercury and Venus here and here, so that tells us the orientation of the image relative to the first point in Aries. In other words, we can figure out the longitude of perihelion of the unknown in this case. These little triangles here, they actually show the nodes. And so, again, we know the nodes of the known planets. We can figure out what the angle of the unknown planet is relative to the known planets. So, with that information, we've got our orbital elements. We now have the ability to reconstruct his orbit. So I did just that. I measured the longitude of perihelion relative to the known planets, and from that I was able to figure out what the unknown longitude of perihelion was and what the unknown longitude of the ascending node was. And it turned out that I was able to recreate his figure exactly in Starry Night. So here are the orbital elements imported into Starry Night. So I calculated them, ported them back into Starry Night, and sure enough, wouldn't you know it, it recreates his figure exactly. And it turns out that the orientation of the planets matches a date of June 4th, 1992. Now, I just searched randomly until I found the right date, just basically played the solar system back in time and hoped that the date that he had in that figure was some reasonable time from now, not super far into the past or super far into the future. And sure enough, it was actually in the fairly recent past, 1992. And it turns out that this date is actually mentioned in his book, so it's pretty obvious that he happened to create this figure when he was also creating the figure for that date, which was completely unrelated on a separate page, but it is nevertheless the same date. So now we have his orbital elements. So he didn't give those out. I haven't seen him give those out in any interview, and I don't think he necessarily meant for that information to be public. Personally, I don't think his so-called planet really exists, and it doesn't really matter what I think, though. I'm going to look for it anyway, just because it's fun. But regardless of what I think of it, let's see here. Okay, so there's our next image. Regardless of what I think of it, I'm willing to look for it. And furthermore, sorry, I'm just checking everything here. Furthermore, even though he didn't give that information publicly to be known, it is nevertheless in his book, and it is possible to figure out exactly what his orbital elements are. Anyone can do that, based on the information he gave. And I'm not going to simply restrict my search to the current position, because I mean, he does say it's an estimate, but it's what he says is the most probable estimate, highly likely to be in that position, and a little less likely to be maybe a few years delayed. But most likely it's going to arrive on February whatever 2016. So I'm actually starting the search assuming he's wrong about that, and that it's still several years out. And he also gave the apparent magnitude, and he says that in fact the apparent magnitude should currently be naked eye magnitude. Now that's really a bold claim right there. He may not realize that, but amateur astronomers are really good at finding naked eye magnitude things that shouldn't be there, like novae, supernova. Amateur astronomers find new supernovas in distant galaxies that are far dimmer than what you can see by eye. And so it's quite a bold claim to say that there's something out there that's naked eye magnitude. Astronomers, even amateur astronomers, would notice that pretty quickly. But he says it's been that way since February. So right off the bat, that should send up red flags in your mind of saying, okay, that's probably not true. But hey, who knows? Anything's possible, right? So let's find out. So right now I'm repositioning the telescope again for image number 3. We've got a lot of images to get through here tonight, because we're going to span a wide region of the sky. Now I'm starting off at the position. Sorry, I have a one-track mind. I can't walk and chew gum at the same time here. I'm trying to slew the telescope and talk. It's not quite as centered as I'd like. Try again. That's close enough. So, right off the bat, that should send up red flags. But he claims it's naked eye magnitude, yet you don't hear about it, in amateur circles. But hey, maybe maybe the government's got trained snipers, and as soon as an amateur finds it, he's shot dead or something. I don't know. I mean, it's ridiculous, but, well, if I disappear off the face of the earth tonight, then you know why, right? That's why I'm doing this live webcast. So, let's see, we're on image 3. So I'm starting off in the position his planet would be in if it were still several years out, not set to arrive till about 2021. And the reason for that is because that's the position that starts off highest in the sky. And basically, I'm working my way across the sky against the rotation of Earth. So the rotation of Earth is bringing the proposed current position of his planet higher into the sky. and my telescope's going the opposite direction, so that it's imaging things in a efficient manner. So we're going to work our way back towards where he says it should currently be. Of course, he doesn't explicitly state what the orbital elements are. He gives vague descriptions of where it should be, that it should be between the constellations of Scorpius and what am I trying to say? Not Scorpius and Sagittarius. Sorry, Capricornus and Sagittarius, which is nice, but that's awfully vague. But it fits perfectly with the orbit that I determined for his planet. That guide star is awfully dim. I'm going to increase the guiding exposure to 2 seconds just to be sure. That's better. We want a good signal to noise ratio on that guide star so it doesn't chase its tail. So yeah, you can see there's a lot of stars here, but most of these are much, much dimmer than what he's proposing his planet would be. I hear an owl in the distance. That's nice. He says, like I said, it should currently be naked eye magnitude, but what if it were several years out, right? Well, you can solve for the absolute magnitude of his planet if you know what the apparent magnitude should be at specific dates. And in his book on page 39, in the bottom left corner, I'll link the book in the video description at the end of this webcast, you can see where he shows it becoming naked eye magnitude, and actually at the start of each month he lists a magnitude for it. And it steadily gets brighter, of course, as it gets closer to the sun. So we know the orbit, and we know what the apparent magnitude should be at all these different points in time. So you can set up a sort of virtual observer and go the other direction, solve for the absolute magnitude by plugging in astrometric values based on the orbit that I've calculated for it from his figures. Plug in those coordinates, plug in the apparent magnitudes at those dates, and figure out what the absolute magnitude should be, and then work back and find out what the apparent magnitude should be, how bright it should have been, or should currently be if it were still several years out. If you do that, what you're going to find out is that it should be at around magnitude 12 or so, even if it were not set to arrive until, say, 2021, which was kind of the upper end of his prediction on where it might be scientifically, but is most likely supposed to be arriving in 2016 for reasons that he says are biblical. So bottom line is that his planet, even if it were still several years out, would be much brighter than any of these very faint stars you see. It'd be more like, I don't know, I'd have to figure out exactly which magnitudes correspond to which stars here, but it'd probably be more like one of these or these. And I've got images from itelescope.net that span this whole region of space that I took over the last couple days using one of their wide field telescopes in infrared. And I'll be comparing those images to my images collected here tonight. If his planet 7X is there, if it's somewhere in this region of space, or even better, if it's where his orbit says it should be, then we should see it moving relative to the images I took with iTelescope. Even over the space of just a few hours, it would move quite significantly, not only because of its own motion relative to the sun, but also Earth's motion relative to the sun, which produces parallax even if it's several years out. That produces a noticeable amount of parallax, enough to see it moving relative to the background stars. So we'll see. Like I said, we have a lot of images to get through, and I don't know if the weather is going to hold out long enough for all of them. I hope it does. And even then, unfortunately, the science is sometimes a slow process. I'm not going to have an immediate answer for you on whether there's really anything there to be seen or not, simply because there's just too many stars here. I won't know. The only way I'm going to know is by comparing to the previous images. So that's going to take some time and additional post-analysis, which will also include subtraction of all these nasty hot pixels. All these very, very bright colored pixels, these are just hot pixels or the sensors. I've got a single pixel that's stuck in the on position. That all gets calibrated out in processing. All right, now we're ready for position number 4. So I've got to load that up here. I got to load those coordinates. Sorry, once again, I have to block your view. And what did I just say? Position number 4, right. Now, there's got to be a better way to do this. Yeah, that's a better way to do this. I'm trying to organize my windows here so that I can enter coordinates without having to keep tabbing between windows. Ow. Of course, in the dark, it's hard to see what keys you're hitting. I'm almost thinking it would be easier to just get up and use the hand controller. 22, 56. So what I've done is I've gone ahead and created a list of coordinates to point at that will allow me to construct this panorama between the position that his planet would be in if it were still many years out. It's set to arrive sometime in 2021, and the position it should be in right now according to his orbit. Telescope slews. That's pretty beautiful. And now I tell the auto guider to check things out. Beautiful. We have a guide star. And now we start the image. So, yeah, it's going to be a long process, unfortunately. But at the end, we'll have a definitive answer on whether he's right at all or not. And also have a very nice, as a side benefit, have a very nice evaluation here of this telescope's infrared capabilities. Usually when I do infrared imaging, I do it with the main Schmidt-Cassegrain, 8-inch Schmidt-Cassegrain telescope, and that works really well. But I don't think I've actually tried it before. I could be wrong, but I don't think I have. I don't think I've tried it before with the wide field refractor. Now, the refractor is a pretty cheap piece of equipment, to be honest, compared to the main scope. The main scope's a very nice piece of equipment. The refractor, it's piggybacked on there. It's really intended for guiding the main telescope. It wasn't built with imaging in mind, but it can certainly do the job, in my opinion. It's more capable than most people might think it is. But it is simply an achromat, and as a result of that, it does have a significant amount of chromatic aberration. You just live with it. And actually, most people who aren't familiar with astrophotography, they don't really mind when I show them the pictures. They think it's beautiful. You know, they think it adds, if anything, that it adds color and prettiness to the image, I guess. To an astrophotographer, including myself, it's kind of grating. It is, to see color fringes like that. But, and especially the star bloating. But when you restrict the light to, say, just infrared light, and you cut out all visible light, I don't know, it seems to reduce the fringing a bit, or at least the bloating. And that's probably because you are cutting out the entire visible spectrum and anything above there, so you're reducing the amount of sort of the range of wavelengths that the camera's picking up to just infrared. And I mean, certainly if I left this thing full spectrum, visible plus infrared light plus UV, you would get awful, just horrendous star bloating, because the problem with the refractor is it doesn't bring all the colors to the same focus point. So the red doesn't quite focus to the same point that the blue does. In fact, there's a good bit of difference there, especially with a simple achromat. And that's worse when you start including really wide ranges of spectrum, to the UV, to the infrared. So a camera like this, it would show a lot of star bloating, a lot of color fringing. But when you cut out 2/3 of that, when you say, all right, I'm going to ditch the visible light and I'm going to ditch the UV light and only look at infrared, you get pretty satisfactory results, in my opinion. I mean, I really can't argue with the images here. The stars are pretty nice and tight. Might be a little bit of fringing and bloating there, but I don't find it to be all that distracting. The camera's thermoelectric cooling is having to work hard overtime, for sure. We're running at 75% to 78% power on the cooler at -5°C, which is cold, but the camera can get a lot colder. But this is a nice, very muggy, very warm Florida summer night, so it's actually rather impressive it is reaching sub-zero temperatures at all. The camera also has a water cooling assist option built in, so you can circulate cool water through it to further drop the temperature, but I'm not doing that. That's frankly overkill for most purposes, unless you're working under really, really dark skies, and I'm not at the moment. This is not even my primary observing site, really, so there's a fair bit of light pollution here. Not to mention the lightning off in the distance there in the west, in the center of the state. Yeah, if you're under really dark skies, really, really good dark skies, yeah, you want to maximize your cooling to get below the sky glow. The night sky has a sort of a natural glow to it. You can see that really well in some videos from ISS, time-lapse videos done on the night side of the planet from ISS. You can see the atmosphere, even though it's pitch black night below. You can see the quite a contrast between the atmosphere and space above it, and that's partly because of atmospheric extinction, partly because of pollution, and, aerosols in the air, and the resulting sky glow of that. So you do have to deal with that anywhere you go, but if you get away from the light pollution, at a certain point, the camera's own thermal glow might be higher than the sky glow, and you don't want that. You want the sort of the rate-limiting noise of the image to be anything but the camera's own temperature, right? You want to maximize your signal-to-noise ratio, so you want to minimize your noise level by minimizing the temperature, at least to the point that something else is getting in the way, whether it's light pollution or sky glow. All right, we move on to position 5 now. Gosh, I forget how many there are. I constructed this list a while ago, so I forget exactly how many are on this list, but I have to scroll a ways to get to the bottom of it, so we're going to be here a while. And it's late, and my mind's already slowing down. What did I say? Position 5, yeah. 57. It's the second time I've heard that car alarm tonight. 22, 48. It's probably a cat jumping on the car, but that's what it is. Oh, hey, what do we got there? Looks like there's a deep sky object somewhere near this field of view. We might get to pick it up, that'd be cool. Just as a side bonus. That's perfect. All right. 5, take an autoguider image. Beautiful. I think in terms of imaging time, at 5 minutes apiece, I want to say it's going to take about an hour 45 minutes of just imaging time, I think. And that's not counting the time it takes me to reposition and set up the next image like this. And then, when all that's done, I get to process all the data. Yay! Also, speaking of processing and calibrating images, probably be a good idea to take a new flat field. I noticed there's some new dust spots on my camera. Somewhere on the, could have been on a filter, or it could have been on the CCD window. It may actually be a different disk configuration than even the last time I saw it, but it's always good to take fresh flat field images, and I don't have a light box for that, but do use, I like to use Twilight as my sort of natural light box on flat field images. So I guess on the one hand, it's not necessarily a bad thing. It's going to take me a while to do this, because ideally I would be using the Twilight to collect new flat fields. Failing that, there's always the option to use an LCD panel with a flat white image on it as a sort of a poor man's light box. I know I probably just made any astrophotographer listening to me cringe at hearing that, because it's not really a truly flat white light source, and you might be surprised at how not perfect that is. But I found it can actually suit my needs for most purposes. It does seem like, it does seem like the sky at twilight actually does provide a flatter light source. At least there, the gradient is consistent, and it's, in a single direction. If you were pointing, say, east at twilight, the bottom of your image might be brighter than the top, but it's consistent, it's smooth. With a screen, you can have variations in the light level from one part of the screen to another part, and it may not be a smooth gradient, so it can be very hard to properly calibrate. But anyway, that's probably too technical for most people to even care. That's how it is. Once you get to this level of astrophotography, you start to care about the little things. Oh man, the light is impressive. I should probably check the radar if I was smart. Just to make sure I'm not about to get rained on. Because it does take a fair bit of time to get all this equipment inside and safe. And I did notice that there was some rain way south of me, but that doesn't appear to be the direction I'm seeing this lightning coming from anyway. No, that rain south of me is dissipating before it gets anywhere close to here. And there is stuff. There's rain towards the middle of the state, but it's moving away from me, not towards me. Where in the world is that lightning? There's stuff kind of to the north, but again, it's way north, and it's not really coming this way. Gosh, it looks like there's a marine warning just off the coast of Tampa. They're getting sacked over there. St. Petersburg area getting hit with some rain, looks like. Man. I'm not near there, so I'm okay. I don't know. I just got to keep an eye on that occasionally just to make sure. This is Florida, and thunderstorms can pop up in the middle of the night. I mean, it's incredible the amount of heat. It's here even at midnight and beyond. What are we at? Well, geez, we're already at 1:10 a.m. Okay. It's a very warm, muggy night, that's for sure. Anyway, I should probably also check and see if there's any questions. I'm sure somebody's asking questions about all this by now. Wait till we reposition here and then I'll check. So if you have any questions, ask them in the comments section and I'll try to answer as best I can. Alright. And yeah, I'm just taking one image of every area because that's all we need for this. I mean, his claim is for such a bright planet that we're going way deeper than that in 5 minutes on this camera and this telescope, no problem. I thought there was, yeah, there's, what is it? Is it just an open cluster? Globular, there's a globular cluster, really? Where? Huh. I don't know. I'm probably missing it. It's probably right in front of me and I'm not seeing it. And it may not even be in the field of view. I don't know. I don't know. Huh. Okay, it doesn't matter. Stop wasting time here. No, don't care. Okay. Moving on to position 6. It doesn't matter. Maybe there's a globular cluster in that picture somewhere and I'm not seeing it. Maybe there isn't. I don't know. Doesn't matter. It was close to the field of view, I think, but maybe even been in it. Next position. Let's see. 1903. Oh, come on. Oh, yeah. It's a good thing that was set properly. I just realized, I'm entering the coordinates here on the computer. It may be asking for them at J2000 instead of the date of equinox. I calculated these for the date of equinox because that's what my telescope expects normally. But I didn't bother to check and make sure that that's what the computer is expecting. And actually it is, so we're good. Beautiful. Okay, slew. And the telescope moves over. That's good. All right. I did set that for 6, right? Yep. Okay. AutoGuider, take an image. Beautiful. We have an abundance of stars to choose from. And we start the next image. Oh. Yeah, that's okay. 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 Okay, I think I'm starting to understand at least what the... Yeah, I'm starting to understand the orientation now of my images here relative to my sky chart. It's like 180 degrees rotated from the normal orientation. I always forget how it is, because the refractor, I think, is different than the main scope, which is, of course, different from the eye telescopes, so it all gets very confusing, especially when it's 1 a.m., but I think I've got that figured out now, and the globular cluster was right around here somewhere, but at this image scale, it could be so tiny that it could be any of these dots. I mean, you can't even tell it's a globular cluster if it's there. So, and I think that's just because the image scale. Let's see, is it? Yeah, it's 3.9 by 3.9 arc minutes, which is like nothing at this image scale. So that's tiny. That's really tiny. Could be, I don't know, could be that. I don't know. It doesn't matter, really. We're not here to image globular clusters, but if we were, I would say that's horrible, and we should switch to the main scope to zoom in on it. Now, you may be wondering, well, how are you going to know it's a planet then if you find this planet 7X thing? Well, we're not trying to image it in high resolution here. We're just trying to see if it's there. If it's there, it ought to be moving relative to the background star. So we should see a fairly bright object, which is in a slightly different position than it was in yesterday when I took the pictures with eye telescope of this same region of space. Now with eye telescope, it was a much wider field of view than even this, and it didn't go as deep in terms of the magnitude. We're picking up even more stars here, but the key is that even with eye telescope, you're still going deep enough, way below naked eye magnitude, to about the limiting magnitude of what his alleged planet would be at, even if it were years away, to say nothing of arriving next year in 2016. So with this scope, we're going way deeper than we really need to in 5 minutes. I could probably get away with 60-second exposures and probably get this done a lot faster, but meh. For the sake of just evaluating what this scope is really capable of and what this camera is really capable of in infrared, I'm actually kind of interested to do this to a more ridiculous level than it needs to be done in terms of going deep, going to really dim magnitudes here. That way I know for future reference how long I need to expose for it to achieve a certain magnitude in infrared with this setup. I've got a bit better of an idea of how it performs on the main scope. I know how dim I can get there. I can reach magnitude 18 without much difficulty, but on the refractor, I really don't know. But just guesstimating here from what I'm seeing, I would think that we're getting to at least magnitude 15 here, maybe even 16, which is actually much better than I thought it would be. And we have more stars. All right. And now we go to position 7. All right, switching coordinates. 1909. 39. I'm sorry, I also remembered I was going to check for questions. Well, I'll do that with this next image. 22, 30, 47. Cool. Autoguider, take an image. Yeah, not as many guide stars this time, but we definitely have one that's really bright and ready for use. Okay. All you need is one. All right, let me see. No, I don't see any questions. Well, I don't know what its magnitude is in infrared. That might be quite a bit different than its magnitude in visible light. But in visible light, this bright star right here, this big white one, is actually 8.4, which is quite a bit dimmer than what you can see by eye. That just gives you an idea of how incredibly sensitive this camera is and how incredibly dim the stars you see here are. Even this big bright one here is not visible by naked eye. It's not even close, really. So we're going quite deep here. Now, like I said, I don't know how that really ranks up in infrared light. That's just the visible light magnitude. It might be significantly brighter in infrared light, and in fact, the fact that these two are dimmer would seem to suggest that to be the case, because in visible light, they're supposed to be brighter. Those other two that were in that triangle there, they were just at the limit of naked eye magnitude, or just a little below it for most people, about 6.7 and 6.25. That's right, just above the limit of naked eye magnitude. So the fact that they appear dimmer in that image suggests that that middle one that looks so bright there is actually significantly brighter in infrared light than it is in visible light. All right, then we have our next image here, and import that. We're going to go to our next position, position 8. Nineteen, 15, 40. 22, 17, 53, 53. All right. Beautiful. All right. I'll go take a picture. Again, we're pretty sparse on choices here, but that should do. Yeah, that'll do nicely. Okay. And it may take me a while to process all this data because it is going to be a lot of data. Each one of these has to be individually calibrated. Normally, I do imaging for an hour on an object and just stack all the pictures into one stack. And that's a pretty simple process, not too tedious at all. But when you're doing 20 different images or 20 different positions, you can't throw them all into one stack quite like that. Deep Sky Stacker won't be so happy about that. So you have to individually calibrate them. And that's a lot more time consuming. And then you have to individually astrometrically solve them, overlay them on top of the previous images, and look for anything moving. So that whole process, it might take me a day or two. So please be patient with me, and don't think the worst when I don't necessarily come back with the results in the next few hours after this webcast. It's going to take me a while to crunch all the numbers here. But I want to be thorough, and I want to be fair. And Saturn over there, isn't it? Tell how late it is by how far into the south, well, almost southwest, really, Saturn is. Man, it's 1:30. Time flies when you're having fun. And it is a lot of fun doing this, too. As much work as it is, it's a lot of fun. Yeah, I was listening to John B. Wells' program where he's giving this interview. I love that guy, John B. Wells. He's got that perfect voice for radio. Very, very deep tenor. And just kind of, just the perfect voice for sort of that mysterious subject matter, subject content. I dare say, and I'll probably be burned at the stake for saying this, but I think he has a better voice than Art Bell ever did. And Art Bell is sort of the legendary king of that whole genre. I'm not commenting on his interviewing technique. I don't know. I mean, everyone has their own favorite, I guess, when it comes to that subject. I love John's voice. Listening to it, he just keeps you on the edge of your seat just with his voice alone, sort of listening to those programs late at night. Occasionally my job calls for some very late night work, and so it's nice to be able to put on the headphones and listen. Used to be, I guess John's not doing guest hosting on Coast to Coast anymore, that's my understanding. Somebody correct me if I'm wrong about that, but I always enjoyed hearing him come on because I knew it was going to be a good night. His I don't know, his method of doing the show never really put me to sleep. It's always good at keeping me up, better than any energy drink could do. George Norrie, on the other hand, not so crazy about. Honestly, half of George's shows, I just have to tune it off because it will put me to sleep. But yeah, I heard about this Gill character before, but I didn't think much of it at the time. I mean, it seemed like another, I don't know, upstart Planet X claimant with his own little pet theory. I just, whatever, here we go again. But I really didn't think it would get that popular, but he's really resonated with people, so hey, what the heck. I guess it's time to put his claim to the test. At least he's published in orbit, even if it wasn't intentional for someone like me to be able to use it to point a telescope so precisely. But when I saw that, because John's program, he showed some of the figures from Gill's book. And when I saw that, I realized, hey, you know what? It might actually be possible to work out what the orbital elements are, even though he won't say. And yeah, I do wish that, someone like, Mr. Wells would ask, their guest for the orbital elements would know to ask for specifics like that, to really separate out the men from the boys. Because anyone can claim, that the sky is falling, but it takes someone with a little more knowledge of astronomy to make a reasonable claim of an orbit and have it actually match their claimed, say, date of arrival and all of that. What am I doing here? Shoot, did I already... What are we on here? 15, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to 9. Right? Right. Okay. Alright. So next coordinates But of course, you know, the whole point of these programs is to not be critical of your guest, I guess, and not really put their feet to the fire, otherwise they wouldn't come on. And what fun would that be? It's all about entertainment, right? So, but that's okay, because in this case we have exactly what we need. Alright, telescope slew. Telescope's been humming along nicely since the motherboard replacement, but it is making new noises it didn't used to make. I still don't know why, but it doesn't seem to be impacting performance at all, so I'm not going to second guess it. Pointing accuracy's just been beautiful, actually. Knock on wood. Okay, next image. Go. On the good news side of things, you certainly get to see a lot more of the sky than you normally get to see during my webcast. I mean, we're covering a lot of ground very quickly here, but the bad news is there's not much to see. I mean, there's just not much of interest here. It's just stars, stars, stars. We're looking very close to the center of the Milky Way here, where we started close to the center of the Milky Way, and we're moving off from that position. So you're looking through the plane of the galaxy a lot, and you're generally not going to see other galaxies, distant galaxies, because you'd have to be able to look through our galaxy. It's basically providing a sort of a block on that. It's all the gas and dust between the stars, not to mention all the stars themselves, obscure you from seeing galaxies far away. So pretty much all you're going to see is star after star after star after star, and if you're really lucky, maybe an occasional nebula. And perhaps a globular cluster here. Hey, what's with that? The tracking jumped in a not cool way. Not sure what's up with that. I'm going to reset the exposure just in case. Just because I like it doing that. Just auto guide. We were only, what, like 80 seconds into it there? I don't know why it jumped like that. I'd rather just start it over. If you're only at the beginning of the image, may as well. Better than waiting the next, 4 minutes only to find out that you have to retake it anyway. And I was just singing your praises a minute ago. Knock it off. Yeah, I talked to my telescope. I'm not crazy, though. No. Okay, somebody's asking, do you have to manually scan each image with your eyes after processing? Or do you have software that can spot a deviation? Says John B. Wells was let go from CTC because he ventured a bit too deep into the powers that can't talk. The powers that be a control system was starting to upset the apple cart. C2C equals control opposition. Excellent explanations and exploring. Thanks for doing this. My pleasure. To answer your question, I guess it's just the train. Well, of course I heard the train whistle, but heard of this roar. It kind of sounded like, you know, maybe distant rain or something. I'm just looking up, like, there's no clouds or anything about to dump on me, are there? No, it's just the train. I'll just be going by eye because we're dealing here only with fairly bright stars. I mean, obviously, there's a lot of dim stars here, but the claim is that his planet is naked eye magnitude right now, or even if it were, you know, years off, it would still be magnitude 12. That's fairly bright. So it's a fairly limited number of stars I have to scan and search. I mean, we're talking, you know, the major ones here. So yeah, by eye will be sufficient, I think. Now, if I get down into some of the dimmer objects, I'll probably find asteroids and things like that, which are moving. You know, really dim stuff. Magnitude 16, 17. Well, I don't know if I'm getting down to 17, but, you know, really dim asteroids and things. But I'll be here, you know, all week cataloging every single little magnitude 15 or dimmer asteroid that I find. Across this much space, yeah, you're going to run into them, especially this close to the ecliptic. So, honestly, I don't want to have to sit here and catalog every single magnitude 15 and greater asteroid from here to Kingdom Come, because 99.9999% of those are going to be previously known, well-established asteroids anyway. We're talking main belt asteroids near the ecliptic, not necessarily NEOs. NEOs stand out because they move a lot. Near-Earth objects, they move so quickly that even in a 5-minute image like this, which is fairly short, they will form visible streaks which move along with time, and I'm not seeing that here. Those are much more rare to run into, and they can be just about anywhere in the sky. But along the ecliptic, what you're going to find are the main belt asteroids, and you'll be here, like I say, from now till Kingdom Come, recataloging all known main belt asteroids. So that's not really my objective here. The objective is to look for, you know, this particular object, which has a certain apparent magnitude to it. So to answer your question, yes, it's a visual search by eye, but I'll also be releasing, of course, all the images, including the eye telescope images that I'm comparing against that I took the last couple days, and the images I'm taking tonight. The astrometrically solved images will be linked in the video description, and you'll be able to go onto that page and download it, whatever format you want, whether you want the FITS file, the raw FITS data, or if you want a KMZ file. The FITS data will have the WCS, what they call World Coordinate System, information embedded in it. Basically, the astrometric solution will be embedded in it, so you can open it up in professional software and point at a pixel, and it'll tell you exactly what those coordinates are. You can also align it. You can, you know, compare it to other images, co-register it, all that stuff. Or if you want, for the, you know, the easier to use sort of lay software, Google Sky, everyone uses it. I hate it, but, you know, the good news is that the same link will also give you a link to a KMZ file that you can download and open in Google Sky. So if you want to use Google Sky, you can. And really, the one good thing that Google Sky is good for, and I like it for, is the fact that you can crossfade between images. I don't care for Google Sky itself, or even the all-sky mosaic they have, because you can get that in a much higher quality from the original Sky Survey sources. But the one good thing you can do with Google Sky that saves me time is the ability to crossfade very quickly. You just grab the crossfade bar, you slide the bar, and there you go. So you can crossfade between two sets of images, not just their images, but your own images. So by overlaying astrometrically solved images from my telescope and from the images taken tonight, I can crossfade between those two very quickly and scan across all the images simultaneously, all at once, and crossfade them, and very quickly find out if there's anything moving. And anyone else can check my work and make sure I didn't miss anything. So that's how that's going to work. And the nice thing, again, about Google Sky is everyone has it, so it's not like most people would have to go out and get something they didn't already have. You can just download the KMZ files, and that's it, away you go. Moving on to the next set of coordinates, 19, 27, 24. It's 19 hours, 27 minutes, 24 seconds for those of you playing at home. Negative 21 degrees, 56.06 declination. Negative 21 degrees, 56 minutes, 7 seconds. No, sorry, it should be 6 seconds. 6 seconds declination. Is that right? Yeah, that's right. All right, telescope slew. Beautiful. So we got that set. Auto guider, take a picture. Okay, we have 1 star here. I'm going to crank up the auto guiding exposure length to 3 seconds, just so we get good signal to noise. Beautiful. And take the picture. With a wide field telescope like this, it is honestly pretty forgiving of any tracking or guiding error. I mean, basically even a budget mount could do this in terms of tracking accurately enough for this telescope, because it's such a wide field of view and the pixel scale is relatively high. You know, you're dealing with I don't know, what is it, 2 or 3 arc seconds a pixel probably. So it's not super demanding. This Elx 200 mount has no problem with it at all, really. I mean, normally I really kind of have to be on my game to get good images out of the main telescope, which is much higher focal length, and you're dealing with a little bit more demanding tracking out of the 8-inch cast ray. It can still be done, which surprises some people. When I talk to other astrophotographers who work with higher end equipment, they're shocked that I'm able to get the pictures I get out of this equipment. But I don't have the kind of money to be throwing it around on astrophysics mounts and plane waves and all that. I mean, it's nice, yeah, and it would make things easier, yeah, but you can get a lot done with what they would say is outdated equipment. It was still, this equipment was high end in its day. In the mid to late 90s, this was top of the line for consumer grade scopes. And I think some of those old timers, who moved on to nicer equipment now, have kind of forgotten what their old equipment really was capable of. Of course, back then, digital cameras weren't as fancy, and auto guiding was even trickier. But taking an ST2000 like this, which is, it's a little out of date, but it's still a very powerful camera. Putting it on this Elx 200, it's really worked wonders. Self-guiding has been very important in my experience, but there are ways to do off-axis guiding and piggyback guide scope guiding that works quite well too if you know how to do it properly. There's just more pitfalls there with the flexure and everything. Actually, who is it? Is it Espig? It might be Espig. I could be wrong. Somebody has a new product out there. I think it's Espig. That's designed to solve the flexure problem. So flexure is where you have a guide scope running on top of your main scope, and you're trying to guide through a little scope while you take pictures through the big scope. The problem is if one of those scopes flexes relative to the other, if the mounting rings that hold it in place don't hold it perfectly rigidly, if the tube itself flexes as the weight distribution changes as it moves through the sky, you'll get trailing stars. You'll blur your picture because what the guide scope sees and what the guider sees is different than what the main scope sees at that point. So that's a major problem, but I think it's SBIG. Like I said, I can't remember for sure, but I think it's SBIG that came up with this new product that they debuted at the. Well, I'm not sure that they debuted it there, but I saw it first at the at this NEAF, Northeast Astronomical Forum video, and basically what it is it's an artificial guide star of sorts that attaches to both of your scopes. And I'm trying to remember exactly how it works. It's like, how does it work exactly? It's a fancy thing, but I think the way it works is it's projecting from one telescope into the other, or something. I'd have to look again. It was really clever, and I think I want to say it like projects the light from one telescope into the tube of the other through a prism, like a periscope type system. And the idea is the artificial guide star it's creating will move if you get flexure. It will move in the same way that the flexure is occurring, and by guiding on that, by examining how that's moving, the guider can take that into account and compensate for the flexure. Okay, the image is done. And move on to 11. Anyway, it was really clever, but it's a fairly complicated solution to a problem that fortunately I don't have right now with the ability to do this kind of imaging, self-guiding. Let's see. Okay, 1933, 42, negative 21, 43, 49. And then we slew those coordinates. Beautiful. Okay, take an image. Perfect. Curiosity, how many pictures do we have left? Oh, we got plenty. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're just past the halfway point, essentially. But we're getting there. We're getting it done here. Let's see, any other comments? There's another comment that's come in. Let's see. Is the area you're scanning an area in Google Sky that's been blacked out? It's an interesting question. No and yes. That's a cryptic answer, isn't it? No, in the sense that if you took all the images that we're taking tonight, you overlaid them on Google Sky, that whole area would not be blacked out. But there are spots in this general region that are missing or corrupted. There are little spots along the way. There's a couple of them where the image data in the Google Sky Mosaic is just corrupted for whatever reason. Again, Google Sky Mosaic stinks. I hate it. It's not as high quality, and it has glitches like this, which don't exist in the original sky surveys that the images are drawn from. Google didn't sit outside with a telescope. They didn't hire someone like me to sit outside with a telescope to take these pictures for them. They didn't get the pictures themselves at all. What they did is they used pre-existing pictures that were already out there from all sky surveys that were conducted decades before Google ever came along. And they took those pictures and they stitched them together to make their all-sky mosaic and put it out there. But they didn't really problem check it. They didn't really error check it for gaps and for problems that happen during their processing for whatever reason. And so there are missing areas that aren't actually missing. They're not actually missing from the original sky surveys. And what you see most of the time when you're looking at Google, not always, but usually it's a digitized sky survey image, usually. 9 times out of 10. If you know what to look for, you can spot them by eye, and right away it's pretty obvious it's a digitized sky survey image. That's the case here. The gaps, such that they are from the digitized sky survey. If you go to the digitized sky survey, those gaps don't exist. The digitized sky survey is a scanning of the old Palomar film plates, the old Palomar POS. Generally what they use is the POS 2 scans, the Palomar Sky Survey 2, also known as POS 2 / UKSTU, which was the Southern Hemisphere equivalent, which was a sister telescope, practically identical, that conducted the Southern Hemisphere survey, half of the sky survey. And because we're working here in southern declinations, negative 20 degrees, you're really talking about the UKSTU pictures. Anyway, that's a long rambling answer. Basically, there are little spots along the way here that are missing if you look in Google Sky, but they're not missing from the sky survey. So if they wanted to hide something, they didn't do a very good job of it. And in fact, you can actually go get the original sky survey pictures, the original negatives. You can actually examine them in person. There are original copies of those negatives that are present in a couple of university libraries around the world. I visited one of them, which is how I did my Google Sky Mysteries video. So if you check that out, you'll see an actual missing picture from Google Sky, the actual picture that was literally missing from Google Sky. I went and grabbed the negative and took pictures of it and analyzed what was really there or not there. So you can check that out on my channel as well. So I hope that answers your question. So yeah, I guess that maybe that adds a little mystery to it for the evening. Yes, there are little spots along the way here. I couldn't tell you exactly where off the top of my head, but there are little spots along the way that are missing from the Google Sky Mosaic, and we'll be covering those areas, I think. I think it was close enough to the orbit of this proposed planet that we will be running over those spots. Okay, next section, number 12. $1939, 38. Negative 21, 31, 56. There's no real significance to the coordinates I'm reading out here, other than they're where my particular telescope needs to point to make this mosaic of its own. Basically, I used Starry Night to plot the coordinates I would need to point out to construct this mosaic. In Starry Night, I was able to put an overlay of my telescope's field of view and moved it along the orbit of this planet, leaving a little bit of overlap on each image. Let's see. Okay, let's take an autoguided picture, leaving a little bit of overlap on each image based on the field of view of my telescope. So a different telescope would have different coordinates it would be pointing at in order to construct a mosaic like this. And here we run into a bit of a problem. No guide star available. Make sure there's no cloud. I don't see one, but my night vision's so completely ruined right now, I wouldn't be able to anyway. I don't really see any indication of cloud cover. Okay, we do have a star here. Good. We just needed a longer exposure. All right, let's go for it. If I want to get really fancy, what I should have done is not only planned out where I was going to point in order to make this panorama, but also plan out what guide stars I was going to use along the way, and make sure that that lined up, made sure that there was at least one guide star at each position. And I didn't really do that. You'd have to set up a second field of view. You know, that is something I should do, though, is take a picture with each CCD here. There are two CCDs on this camera. One is for imaging, taking these color pictures in high resolution. The other is a low resolution guiding CCD chip. It doesn't have as many pixels. It's not as big physically, but it's simply there as a monochrome chip for guiding, for picking a star and making sure the telescope doesn't wobble. You get periodic error even with perfect polar alignment, unless your scope's really high end. So it will drift slowly back and forth a little bit over a regular period, the period of which matches the gear, whatever the period of the gear is, however long it takes the gear to complete one rotation, which in my case is about 8 minutes. So to compensate for that, you do two things. You do periodic error correction, which is an internal computer system which corrects for that periodic error as best it can. But it has a time resolution of 2 seconds, which is good, but it's not perfect. So you train it to do that, and that kind of takes out the average periodic error and brings it down to a manageable level. And then you try to take the rest of it out as best as possible using auto-guiding. So that's the basics of deep space astrophotography right there. So that's why you're seeing this other little window over here. That's the guide star. Now, auto-guiding, contrary to what some people think when they first get into the hobby, they think, oh, if I can just do auto-guiding, it's going to cure all my ails. I won't have to worry about accurate polar alignment. I won't have to worry about periodic error. No, wrong. Not true. Can't be said enough. It's not a cure-all. It doesn't fix all your problems. You still need to do an accurate polar alignment. If you don't have an accurate polar alignment, you will get field rotation. So even though you might be guiding perfectly on a star, this chip that's taking this picture is up here. Physically, it's above what you're seeing here in this image. So even if you've got it perfectly trained on a star up here, if you don't have accurate polar alignment, you get field rotation. And so the stars, especially down at the bottom of your image, are going to form nice little streaks, circular, in fact, concentric circles around the point at which you're guiding, the guide star, which is way up here somewhere. So because of the physical separation between the chip up here and the chip down here, and especially the size of this chip down here, you're going to get noticeable field rotation, and you're going to have ugly images. So no, it's not a cure-all for bad polar alignment. It's also not a cure-all for bad periodic error correction or no periodic error correction. If your mount doesn't have periodic error correction and it's one of these budget mounts with lax tolerances on, ooh, that's not good, we just lost the guide star. Stop! Okay. Don't know what that's going to do to my image, but oh, we've got a cloud, all right. Ooh. Ooh. Well, we'll just bear through it here. That might ruin the picture, but if necessary, we'll just take it again. Where was I? What was I saying? Oh, it's also not a cure-all for periodic error, because if you don't have periodic error trained at all, it's going to be moving, the periodic error is going to be moving the star too fast for, say, a 4-second exposure on a guide star to fix. You're just giving it too much to handle. And so you overwhelm the ability of your guiding to fix the problem. Now, here's a problem that no amount of guiding or polar alignment or periodic error training can fix, and that's cloud cover. So, they're fast-moving little white puffy clouds. Looks like they're clearing off now from the spot where the scope's pointed. Coming in offshore, let me check the weather, check the radar, make sure we're not about to get rained on or something crazy. I don't think we are. And that picture looked okay. It'll do, pig. So I'm going to call that done for that picture. We've got enough depth in this image to accomplish our purpose here. Okay, let me just check the radar here. Oh shoot, I just closed the stupid window. There. Well, the rain down south really dissipated, that's good. Yeah, the rain's all dissipating. Oh, except, what in the world? Oh, that's just scared me. It looked like there was a storm forming right near me, but it's just, I'm pretty sure it's just noise from the radar beam or whatever. I don't know what they call that, but it's just noise. It's not a real thing. If it were, I'd be getting rain right now. So, yeah, it's just temporary cloud cover. All right, let me move. I'll slew the telescope here to its next position. I don't know. I mean, if we get really clouded up, we may have to make this a two-parter instead. We've got over halfway done, though, so that's not bad. We got a lot done tonight. And I'm not giving up yet. But if we have to, like I said, we'll just break it into two parts. And, you know, I'll analyze the images I've collected so far tonight. Just make sure, verify there's nothing there. $35, 19, 30, 45, 35, negative 21, 18, 01. I think It's going to be unlucky image number 13. Oh, that figures. Yep, 13. Slew the telescope. And it moves into position. Cool. Let's just see. Do we have a guide star available? I don't even know if we have any stars available. It might be still cloudy there. I don't know. Oh, we got a guide star. That's good. Let's take it down. We'll leave it at 4 seconds just in case we get a partial cloud. See, this wide field telescope is so forgiving, I don't really worry or care. Maybe I should, though. The breeze is picking up from the west. That's interesting. That's not enough to matter. Okay. Well, we'll try it. We need every minute we can get, right? So, start the image. I can't guarantee I won't get clouded up again here in 5 seconds, but I don't see any imminent cloud. At least not where the telescope's pointed, so we'll keep going until we can't go anymore. I think there's about 21 images we need to complete, and we're on 13 out of that, so like I said, we're over halfway there at least. Even so, we haven't reached the point yet where this so-called planet's supposed to be. Let's see. While that's taking, do we have any more questions? Comment there from Black Sun Dark Star. Thank you very much. Appreciate it. Yeah, we're having a look. I don't mind looking. Like I said, it's actually kind of nice. It gives me a chance to evaluate the infrared capability of this scope. Seems like the guide star got dimmer suddenly. I'm thinking that might have been partial cloud cover. But it's receding now, or at least it seems like it's getting back to normal. That's why I left it at 4-second guiding exposures. Because if it completely loses the signal, it can chase its tail a bit and screw up the image worse than if you weren't guiding at all. Unfortunately, the software tends to make guesses when it doesn't really know for sure where the guide star is. It just kind of throws a dart at the wall and says, I think that little spot of static is the star. I'm gonna go there. Let's see, we're getting that again. It's starting to dim again. I don't see. Well, I guess I see some thin cloud cover. That might be causing it. Oh gosh, that's really. Oh god, no, stop. It's getting, yeah. Yeah, that's at the point at which it starts throwing darts at the wall, so I stop it. And we got 93 seconds left on the exposure. I'm just going to let it finish without guiding and see what we get at the end of that. It's just that at a certain point, it just, well, yeah, I guess I'll crank it up to 6-second guiding exposure. That's a long, long guiding exposure, but perhaps it's better than none. And really, then maybe not. I don't see it. I don't see it. I don't see it. Yeah. We may be toast on this image. Yeah, and then I just bumped the camera a little bit when I tried to get up to kind of gun sight the telescope and see where the clouds are in relation to that. I think I bumped it, so I probably totally ruined it. As if the clouds didn't ruin it already. I think if we're patient, we'll be okay. It looks like it's clear behind whatever this little cloud bank was that came through. And I think we're already in the clear, so I don't know. It's hard to say. The autoguider's not running. Why are you pausing it? Why are you trying to pause it? Okay, wow. Apparently, it didn't like that. All right, we're gonna have to do that over. It got hung up trying to stop the image, probably because I stopped the auto guiding and restarted the auto guiding. I think that caused a glitch. Well, that's neat. All right, let's do 4 seconds again. Let's do 5 just for good measure. 4, 3, 2, 1. Yeesh. Do we even have it? Okay, I don't even see the guide star at this point. Crap. All right. Let's turn off autosave for a second. I just want to see what the situation is with the clouds. The other nice advantage of having such a super sensitive camera is you can actually see the clouds going in front of the telescope. Like that. Okay, yeah, that's cloud cover right there. That's really severe cloud cover. You could see stars occasionally peeking out, but all this white, that's cloud. And you can see how it's moving here in a few seconds of time. That's bad news. That's bad news. Seems like it's going away. Is it? No, it's coming back. Never mind. Spoke too soon. Yeah, we're gonna have to be patient here and just let the clouds do whatever they're gonna do. We got this one little band of clouds which is parking itself right where the telescope's pointed. That's just my luck. And you know, I look around the rest of the sky, and okay, so off to the northeast we've got this bank of clouds that just went over. And in the east, south to the southeast, we've got some thin clouds, which is kind of what we're looking at here. And then off, well, just about everywhere else. High in the sky, in the west, until you get very low on the west. It's been cloudy there all night, but Um, High up in the sky and all that, it's clear. There's not much going on. It's just right where we're looking is trouble. I think it's gone for the moment. I mean, we're playing with sucker holes here in this part of the sky, where we get a little bit of a clearing briefly, but you're sucker for starting your image because you're just going to get clouded up again before you can complete it. But we're going to try. We're going to keep trying. Okay, autosave on. Bidding 1 by 1. 1, 2, 3, 4, 5 minutes. Okay, we're starting the image again. So we're still working on section 13 here. Just gonna have to let it take the image again. I'm just gonna verify once again with the radar that there's nothing rain-like in these clouds. I don't think there is. And I don't see anything but ground clutter. That's fine. At least we have this guide star as a canary in the cage to let us know when when the image is getting ruined. Yeah, we're still waiting on this first image to come in after our interruption here from the clouds. I think we're in the clear for now. Fortunately, might actually make it through at least this image before getting interrupted. My other concern that I may not be fighting fast enough against the rotation of the Earth here, because where are we pointing? We're pointing. We're not quite to the meridian yet, so where we're pointing, the coordinates we're pointing at will continue to rise a little higher before they start to fall again. But as they get further off to the southeast, fortunately, I've got a tree in that direction that they're going to hit pretty quickly. So we really have to pick up the pace here. Just hope we don't. If we keep getting interrupted, we're in trouble. Might already be in trouble. I don't know, but I had this planned out in my head at least that this all should have been able to occur before we hit the point where the coordinates we're pointing at are starting to set behind trees and the like. But that was assuming no interruptions from clouds and the like. I was really hoping to have just a solid, clear pass at this. But, of course, reality may not have that in mind. Okay, we got a good image there. Looks nice. We might have had a little bit of a thin cloud pass through, which is causing this gradient here. That might be accounting for that. But it's good enough. Let's move on to the next section. Okay. And we're going to point at 1951. 18. Negative 2104. 15. And then we slew the telescope to these coordinates. Beautiful. On a guide. Take a picture. Do 4-second guiding. Even that may not really be enough. Let's stop that for a second. Let's do 5-second guiding. Just want to be sure we got a good signal to noise ratio here. That's better. What's that? That's a plane. Just saw this bright light through a tree, and I'm like, didn't know wasn't expecting to see a planet there. I'm like, hey, there's something there. Thought maybe it was a satellite. But then again, that'd be really weird to see one at this hour. But no, it's just a plane. And fortunately for me, I don't think it's going to pass through the field of view. No, it's far enough over. It's not a problem. I could see another cloud bank down there low in the southeast. It might come up and bring us trouble. Hopefully not before the end of this image. It's funny, those clouds in the southeast actually, some of them look like they're just moving south and sort of southwest. It might not come up in the field of view at all here. That's good. Oh, there's a little one. No, there's a little runaway from the rest of the cloud bank pack. He's kind of coming up towards my field of view. It's just a little, oh gosh, it's just a tiny one. We got less than a minute here on this exposure, but I think I can already start to see dimming of the guide star, maybe? Yeah, might be getting some dimming of the guide star. Come on, 40 seconds. Oh gosh, come on, these 5-minute pictures are killing me. And oh god, oh, that guide star's getting dim. And really, the thing is, we're getting close enough now to the, we're over halfway there. We're getting close enough now to the predicted point where it should currently be, this hypothetical planet, that we shouldn't have to do 5-minute exposures. It's supposed to be naked eye visible. Even if it's not quite naked eye visible, we're going way deeper than that. All right, we got our picture. There we go to section 15. So, for the last few images here, as we scan the region of space where it's supposed to currently be, or close to where it's supposed to currently be, we really should be able to reduce the exposure length, down to 60 seconds. And that would technically get the job done. I mean, I think that would satisfy the claim here, but we're doing better than that. We're trying to be thorough here. I'm trying to be as fair and as thorough as possible. So let's move on. We are at 19. We need to go to 1956, 46. Negative 20. 50. 30. Beautiful. Okay. Let's just see what the situation is here. Guide stars. Not seeing much. Might be getting clouds again. I should say we're probably getting clouds again. Let's turn off autosave for a second. Let's go to 5 seconds, 3x3. I just want to see here what the situation is. Binning 3x3 increases the sensitivity quite a bit. I don't really see any cloud indications. Yeah, it looks pretty cloud-free at least. Yeah, we're going to call that cloud-free. One by one. So, 5-minute image, here we go. I mean, technically we should be able to get done in the next 35 minutes or so, plus whatever time it takes to reposition the telescope and all that. But with these stupid clouds, they keep getting interrupted to the point that we can't quite finish tonight. I don't know. Hope that's not the case, but we'll see. We'll certainly give it our best shot here. Oh boy, that guy starts worrying me. Oh gosh. Maybe I'm worrying over nothing. I think there might be a little bit of cloud cover there. Oh yeah, definitely is. Ooh, crap. Okay, stop guiding, stop guiding! We'll let it finish out unguided. See what we get. It's funny, when I stop the auto guiding, I can hear my processor fan slow down. It's like, I don't know why auto guiding would take up so much of my processor overhead, but I can hear the difference there. Alright, that's not bad, right? No, that's not bad. That's a decent image. That'll do. That'll do. Okay. We may have lost part of the last minute there from cloud cover, but it doesn't appear to have reflected enough light to have disrupted the image, so we're going to keep moving. On to section 16. Because if we keep dilly-dallying around trying to get the absolute perfect image, we're never going to get done. And like I said, at this point, really, you don't have to go to ridiculous magnitude lengths to prove the claim wrong. All right, 20, going to 20, 02, 32, negative 20, 36, 36, 12, sleep telescope. Good. Now let's see what the auto guider says. Probably still got, well, it might have moved off. I think it might have just moved off, wherever that cloud was. There we go. Auto guide. Imaging. Curiosity. Yeah, we're still pretty well above any roof or tree lines, so we've got time. Hi, Test. Welcome to the show. So, if anyone's just joining us, to give a brief overview of what we're doing here, because it has been, gosh, how long has it been? How long have I been webcasting? I can't find the running time. Well, it's been a while. Uh, where should I start? Okay, so I was listening to John B. Wells' program recently, where he had on a guest named Gill Broussard, who claims to know the position or orbit of a planet X, which he calls planet 7X. As for why he calls it 7X, the best I can determine is he just wanted to make the name different so that it wasn't as loaded a term, it wasn't commingled with other claims about planet X. It was very nice of him. Anyway, he published a book where he claims to show its orbit and that it's going to wreak death and destruction upon the Earth very shortly next year. Basically, he gave a perihelion date of February 2016, said it would make a close encounter with Earth in March 2016, and he showed the orbit. And if you look at the orbit, you can determine what the orbital elements of his proposed orbit are. I'll just cover this one more time. Apologies if you've already seen this, but we're just going to go over it again real quick for those just joining the program or those who joined late while the next image is being taken. Come on. All right. Here's my full screen. All mirrors. Okay, so all right, quick. We got 90 seconds left. So here's a figure from his book, Gill's book, which claims to show the orbit of this planet 7X. What he probably didn't realize is that he was using Starry Night here to show this, and Starry Night shows the longitudes of perihelion and the ascending nodes. The longitude of perihelion shows these little pips, and we know the longitude of perihelion of Mercury and Venus, so we can determine what the longitude perihelion of the unknown is by measuring it and the angle relative to the knowns. Same goes for the ascending nodes of the orbit, which are shown as little triangles on the orbits, so we can measure that as well. Then he gave the orbital period as 319 years, so we know what the semi-major axis is because that's a direct function of the, you can express it as a function of the orbital period. And because he gave the perihelion date, we know that as well. We know when it's supposed to arrive at this point. So from all that information, you can actually calculate the exact orbital elements. And I did that and recreated his orbit in Starry Night. And look, there it is again. Basically, it's the same thing. I've recreated his orbit, and it matches his figure, this figure that he shows. So here are the orbital elements, and I'm using that now to search for his so-called planet. Perfect time. We got 6 seconds left on that picture. So let's go back to screen sharing, just this screen. So we have those orbital elements, but we're actually searching even more than we need to. We're searching a wider region of space under the assumption that he might be a few years off on the arrival date. He said it was highly likely to arrive in February 2016 at perihelion, but maybe it's a few years off. So we started searching under the assumption that it was a few years off, at least showing up no earlier than 2021. And we're searching that whole region of space just to make sure, just to cover the claim. And we're now moving on to the next section of space that we need to search. Section 17. Yeah, it's a lot of sky that we're covering tonight, very quickly. Now, he claims that it is already naked eye magnitude. I know, that's ridiculous, but that's what he claims. He claims it reached naked eye magnitude in February of this year. Not next year, this year. And given the magnitudes that he shows on page 39 of his book, Even if it were several years off, it would still be about magnitude 12, which is easily detectable with amateur equipment like this. Just to really go all out and make sure there's no excuse for it not showing up, I'm also searching in infrared. This is an infrared searcher. These stars you see are all in infrared. This is not visible light. Which is why in some cases the magnitudes of the stars are different than what we see in visible light. There will be a star that's brighter than the stars next to it where it should be dimmer. And the reason it's brighter is because we're looking here in infrared, and it might be an infrared bright star, like a red dwarf or who knows what. So, actually, probably the most popular infrared bright star would be CW Leonis, which is a carbon star. It's not a red dwarf at all, but most of its visible light is obscured by gas and dust. Okay. Now we slew the telescope to these coordinates. Guys with me? Okay, good. Alright, let's take an autoguider image. Okay, we got one there. Perfect. Auto guide. You know what? No, that's not even. I think this one's a little brighter. We'll do that one. Alright. Now I'm going to move this case before I kick it over. Hit something important. I need to find a better place for this thing. Oh. There we go. Moved it on the porch. Oh. Let's see. checking the radar here again, make sure nothing unexpected is popping up. Florida in the summertime can be somewhat unpredictable even at night. Looks like Chiefland might have got some rain earlier. Alright, enough of that silliness. The guide star canary is holding strong, that's good. I think we're reasonably free of clouds at the moment, and with that I'm sure I just jinxed myself. But so yeah, at the end of all this madness tonight, I'll post a link to Gill's book. Be warned that it is over 100 megabyte download, so if you're on a slow connection, you're going to be waiting a while. It's a PDF. And then I'll include links to pictures in, looks good. I'll include links to the iTelescope images that I'm using for comparison to these images. And, oops, let me do that. Stop. And then, of course, once I'm done processing these images and have them available as links, I'll post those as well, but that will be later on. At the moment, I don't think I have... Yeah, I don't. I've got most of the iTelescope images posted. Well, not posted, but uploaded. But there's two more I haven't uploaded yet. I had to reshoot them. So I haven't had a chance yet to finish processing those and upload them. I'll probably do that once at the same time I upload these, so that'll probably be a little delayed, a little later. What am I doing? Okay, we're going on to 18 now. Alright. If I lose count, if you see me lose count in assigning numbers to these images, don't worry. I'm not losing count on the coordinates because I'm just going down the list. I'm checking what coordinates the telescope's currently pointed at, and I'm just pointing it to the next on the series of coordinates that I have to point at on my list here. So even if I lose count in terms of just naming them, it's just a naming convention anyway. It doesn't matter. I don't think I'll lose count. I hope I don't, but if I do, it's not a problem. It doesn't actually mean anything. That's what I'm trying to say. Alright, slew telescope. Perfect. And auto guide or take a picture. Beautiful. Auto guide. settled here. I think it's going to need to adjust that star a little bit. Yeah, there we go. That's good. Starting the image. Let's see, what are we at now with altitude? Yeah, we're 170 degrees azimuth. Almost 41 degrees altitude. Like I said earlier, I'm working against the rotation of the Earth here. I started at the point that was highest, and I'm working my way eastward from that. So trying to do things efficiently here, and we're sticking pretty close to where all the images are being taken at very similar azimuths and altitude. Well, somewhat, as much as possible. I mean, really, we're doing 5 minutes here to cover about 1.5 degrees of sky, probably. And the sky moves at 15 degrees an hour. So let's see, what is that? It's about right? Oh gosh, it's 3 a.m. I can't do math in my head. Sorry. Break out the calculator. Yeah, it's about right, actually. 1.25 degrees. Is that right? 1.25 degrees every 5 minutes? Okay, if I'm not completely delusional right now, which is entirely possible. Wait, I'm completely delusional, aren't I? No, I'm not. Okay, divided by 60 times 15. Right. Okay. Like I said, I can't do math at 3 a.m. It just doesn't work for me. My head stops working. So, yeah, 1.25 degrees every 5 minutes, and we're working at a rate of about 1.5 degrees every 5 minutes, roughly, sky covered. But we have a little bit of overlap, and we have a little bit of downtime in repositioning the telescope. So really, we lose a few minutes there. Not to mention the clouds that interrupt us. But the idea of it, when I set this up, was that we would be maintaining a relatively constant altitude and azimuth, where the scope is pointed at roughly the same position relative to the horizon on each image. So you're looking through roughly identical amounts of air, and you're looking pretty close to the meridian. So you're looking kind of close to where these things are hitting their peak in the sky, the optimal position for seeing them. I promise, it all sounded a lot more intelligent, clever, and well thought out when I actually planned all this, but at 3 a.m., I start to lose my coherency a little bit. And it's not like I'm having to drink or take anything to get that way, to get that level of punchy. It just happens. That's what happens. It's 3 a.m. I spent a lot of energy setting up the telescope, operating it, staying out here in the muggy air. It's draining. It's pretty draining. It's fun, but it's draining. The nice thing about the telescope being positioned where it currently is, at the current angle, is that I have a clear line of sight to the dew heater controller at all times, which is nice, because that stupid thing shut off earlier tonight when I overheated the power inverter before I started the webcast. I only had it cranked up to like 60%. The darn thing overheated the power inverter because it's so darn hot out here tonight. Normally I can run at 60-70% in the winter, no problem, but not tonight. And there's our next image. Beautiful. And we move on to section 19. So I go right on the money on that count. Okay. And we go to 2019. 25.6. Let's round up to 26. Oh gosh, getting punchy here. Negative 19, 42, 45. Okay. Slow the telescope. That's good. Auto guider, take a picture. Wow, there's a really bright guide star there. That's good. Woo, that thing's bright. Okay, we're gonna do 1 second guiding exposures, not because we need to, but just because that thing's really bright. Okay. And start. Image is looking pretty good. Just a little worried that temperature fluctuation over time would might cause a little bit of a focus issue here, but the telescope's been sitting out pretty much all night anyway, so it was pretty well equilibrated to the ambient temperature when I started, and it's not cooling off much. This is Florida. It's hot as crap down here right now, so I mean, it will cool off a little bit, so I guess I need to keep an eye on it, but it doesn't seem like the focus is drifting too much. Not enough to matter anyway. If it's not tack sharp perfect, well, so be it. But it doesn't look bad. It really doesn't. And like I said, we're going here to much dimmer magnitudes than we actually need to in order to address this so-called planet. It's supposed to be naked eye magnitude, so it should be brighter than anything I see in these pictures. There's nothing here of significance. I mean, just to give you a point of reference, like I did earlier, this bright star right here, this is magnitude 7.78. That's over a full magnitude dimmer than anything most people can see by eye. I mean, for most people, the naked eye limit's around 6.5. You can push it a little past that. You can push it to maybe 7 if you've got really, really good vision. And I don't just mean you think your vision's good. I mean, you have great vision, and you have experience using it. Under dark skies, using averted vision and really maximizing your dark adaptation and all that. So this star is pretty much unquestionably dimmer than anything you can see by eye, and it's one of the brightest stars in the picture. So, and that's way dimmer than this planet's supposed to be right now. And we're reaching the region of sky where it ought to be. It should be somewhere here in one of these final pictures here, based on his claim. Based on the orbit he shows. I mean, he shows this in multiple charts through the book. You know, I calculated the orbit based on the one chart he shows, which actually shows the perihelion points that you can actually measure off of and actually determine precisely what the orbital elements ought to be. But throughout the book, he shows, here's where it was years ago at such and such a date. Here's where it was relative to, you know, Voyager probes and Pioneer probes and all this, blah, 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 blah. And just looking at where it actually appears, where the orbit I calculated appears in the sky, it matches up pretty well with his charts throughout the book. So I know I'm onto it. It's not just that it so happens to look like the one I showed you. It actually is consistent with what he shows throughout his book. And he gave some coordinates to a friend of mine. He wouldn't give the orbital elements, but he gave the coordinates after some badgering for where this person would have to point his telescope in order to see it. Now, that was for his location, which is on the other side of the world from me, and at a different date. So it's not valid at the current time. But I looked at it with my orbit and tried to calculate the same thing, and showed that indeed, in the process of doing the search, I would run right over whatever position he's predicting, or would predict with his with the orbit that he's got. I'd be running right over those coordinates tonight in this final scan here, in these final images. You know, of course, in trying to measure from a little picture in a book, you know, there's always going to be some degree of measurement error, but it's not enough to matter. It's not enough to put it outside of this search for sure. The search is way more broad than that. So I was just looking at it and saying, okay, if I were at my friend's location and searching on my friend's date, you know, with this kind of search covering this region, would I be covering the coordinates that he suggested, that he set up, that he should point out? And indeed, it did. So we're good. All right, we've got that image. Let's move on to 20. I don't see any clouds coming up from the east, knock on wood. I think we might be clear for the final couple images here. All right. 2024, 35, negative 19, 23, 04. Oh, there's a nice little galaxy in this field of view. But it's only like two arc minutes wide. Okay, that's barely ever going to, that's barely even going to show up. It's going to be hard to see if visible at all, so not really counting on it showing up all that well, but hey, whatever. All right, telescope slew. Good. Right. Autoguider, take a picture. Good, another couple bright guide stars available. And start imaging. All right, any final questions in these final minutes? We've got 2 more pictures here to take. Should take about 10 minutes. Black Sun Dark Star asks, once your scan of that area of the sky is complete, will you next be comparing against catalog sky images, or do you need to do another scan of in a few days to look for changes? Excellent question. I did mention this earlier, but I probably should have restated it for you and anyone else who joined late. So the way this is being done, and again, that's an excellent question. In the last couple of days, I've taken images of these same, I won't say these same pictures, but I've taken pictures of the same region of sky using a telescope in Australia through itelescope.net. It was another infrared search with a wide field telescope, which had an even wider field of view than this one, significantly so. This one, oh gosh, off the top of my head, I want to say it's about 1.5 degrees wide field of view. Whatever it is, it's not nearly as wide as this other telescope, which has about a 4-degree wide field of view. So it was able to do this whole process much faster, but not to as much depth in terms of magnitude, but still had a good limiting magnitude around 12, which would be about the magnitude of this proposed planet if it were still many years out. Even if it weren't going to arrive until about 2021, that's about how bright it would be, so we'd still pick it up there. Go away, bugs. Yeah, what was I saying? So I conducted this scan over the last couple of days using that telescope, and I've got those images now, and I just need something to compare against to see if anything's moving, right? So that's what these images will provide. So I'll compare against those images, the ones that were just taken a couple days ago, and if this planet is there, we should see it moving. Even if it were still years out, believe it or not, it would be moving detectably because of the parallax induced by Earth's motion. You can actually test this. You can load up the orbital elements I gave there in that picture, and you know what, that's what I'll do. I'll link to the text file I've got that has the orbital elements in them as well in the video description, if I can remember to do that. You can load up those orbital elements, and you can say, okay, instead of the perihelion occurring in February 2016, what if it were February 2021? And you can look at the position that predicts and how that changes from night to night, and it actually does change quite a bit, enough that you would see it moving in the image. It'd be like, if it were this thing, it would be here, and then the next day it'd be over here, something like that. So we should see it moving if that's the case. So bottom line is I've got astrometrically solved versions of those images from Australia, and the images tonight I'm going to calibrate them, get rid of all these nasty hot pixels, all that stuff, and astrometrically solved all those pictures and include links to the astrometrically solved versions of all these pictures, all 21, and I'll put that into the video description once that's done. That'll take me at least, I'd say that's probably going to take me at least most of tomorrow, maybe even to the next day, to get all these images calibrated, uploaded, and solved. Once that's done, the links will show, the links will allow you to download. Perfect, that picture's done. The links will allow you to download either WCS World Coordinate System embedded FITS files in the original FITS format, or alternatively, you should be able to download KMZ files, which you can open up in Google Sky. And the objective, again, is not to compare to Google Sky's images, it's to compare against the images I took with iTelescope. But I can overlay both of those onto Google Sky. So we're not even really using Google Sky except as simply a slider. That's what it provides, is just a crossfade slider. So it makes it easy to basically blink compare between the images. You could also get a program that does blink comparison if you want. Most people don't have one, which is why I'm making the link available with KMZ available, because most of you guys have Google Sky. At least you can use that to blink compare between the two. But if you prefer to use something more professional, I've also got the WCS embedded FITS files there. So there's that. Yeah, that's it. That's what I thought. Actually, I can see the galaxy. It's right here. That galaxy is NGC 6903. Since we're coming up here on the end of the webcast, I may as well spend a moment talking about this. It's got a surface brightness of 13.8. Total brightness is 11.9, but that's distributed across 2.5 arc minutes in each direction, basically. So its surface brightness is only 13.8. It's a Capricorn. It's in the constellation Capricornus. Classification ESO BARGL. I forget what that stands for. Again, I'm going to blame it on the fact that it's currently 3:22 in the morning. I believe that's elliptical, though. I think that's what that is. The E is for elliptical something, something, something. Okay, good enough. Let's move on to the next coordinates. Oh, God, it's late. The last set of coordinates. Hurrah! Hurrah! We've made it to the end. We have made it without complete cloud cover, without just being completely clouded out for the night. I'm very, very glad of that. 28, 28, 34.9, cloud 35, negative 19, 04, 20. Beautiful. All right. Auto guider, take a picture. And nothing available at 1 second. All right, fine, we'll go 5 seconds. I see one now. Okay. All right, we're good. Auto guide start. I need to change this to 21, right? We're on the last one. I think we're on the last one. Let me double check that. Right, we're on the last one, right? Yep, we're on the last one on the list. Cool. Taking image. Oh, well, it's been a long night, but it's been good. A couple minor hiccups there with interruptions from the clouds, but we got through it. Very good. And I guess the real question then is, after this is done, after we've collected all of our images for the hard work, the search, should we point at something else real quick before dawn and just take a look at something pretty, just for the sake of taking a look at something pretty? What would be a good target? Let me see. We're now pointing far enough away from the galactic plane, from the galactic equator, that we are starting to pick up galaxies like this. There are some others in the area that might be fun, but really they're kind of tiny. They'd be most fun for the main telescope. So I'd have to move the camera, refocus it, all that jazz. Even the pointing might not be accurate on the main camera compared to the wide field, so I'm not sure that that's the best idea. The other thing to keep in mind is I've got the infrared filter on there right now, so we're filtering for infrared light. So anything that's not an infrared light, anything like a nebula that's, I don't know, got some sort of O3 lines or something, it's not going to, I don't think it's going to show up properly. Even hydrogen alpha probably wouldn't. Could do Pluto. Pluto is actually pretty close to the area we were researching. It's a little north of it. I don't think it was in our actual search pattern or search area, but it was somewhat close. We could go back and look at it. Kind of pointless, not exactly pretty. But there is some interesting news coming up in Pluto soon, where the New Horizons probe will be flying by Pluto on July 15th. I just noticed, saw a commercial for some sort of show on Science Channel. They're going to do a special for the flyby. But of course, I'm probably just going to watch NASA TV for the live coverage just to see what's going on there at Mission Control and for the actual duration of the flyby. But I'll probably record the Science Channel show. I don't know. I'm curious to see what they do for a presentation. Anyway, it promises to be interesting and may even hold some surprises for us. There was some hope for a period of time that we might actually find out that Pluto has rings. But so far, I haven't heard any sign of any significant rings, at least. But there could still be some interesting surprises in store for NASA on that. So that'll be happening next month. Be here before we know it, really. That probe's been headed to Pluto for about the last 10 years. So it's been a long time coming. Anyway, even that being the case, Pluto itself just doesn't make for a particularly pretty target in the wide field shot. I mean, it's a needle in a haystack, just finding the thing. And I don't intend to come back tomorrow night just for Pluto, so we wouldn't have a proper animation of it because it wasn't in the original search images. Yeah, we'll pick something else. Downloading light. All right, that's that. Now, hopefully that takes care of it. The only concern I have is I'm wondering if maybe we might have some gaps between the images. We didn't have it worked out well with the eye telescope doing the panorama, but it's possible if I didn't leave enough overlap on these images, it's possible we might have some issues where we have small gaps that need to be covered or something. If that's the case, I might just go over them again with another couple eye telescope passes. We'll see. But I'm hoping that's not the case. Yeah. We'll see how it goes. All right. So let's find something pretty to point out real quick. Ah, bugs. Oh yeah, of course we can do that. Certainly a possibility there. Let's see, where is Andromeda right now? Oh, hey, wish that you love again. Let's see. Practically right in the power line. Andromeda Galaxy. Practically right in the power line. But Right. Let's turn off auto sync for a second, just see how the framing of the shot is. I probably should have done that before I even started auto guiding. Yeah, it's there, but it could be better. Let's frame it up a little bit. It's better. All right. All right. Well, I'm going to leave the telescope doing this. Just going to take some pictures of the Andromeda Galaxy in infrared. Why? Because we can. That's why. It's a good enough reason, right? radar, make sure there's nothing crazy. Yeah. There's more stuff in the Atlantic, but it's too far to matter. Curious to see how this actually looks. I don't think I've done this before. Wide field infrared of Andromeda. I don't know that the picture in and of itself will necessarily be really all that pretty, particularly not without any processing, but the data might be useful to future effort I make in imaging Andromeda. I don't know. Maybe I'll throw it into some stack later where perhaps I combine visible light with infrared light. I don't know. Might do something with it. See how it turns out. Yeah, what you're looking at here is the core of the Andromeda Galaxy. And one of the satellite galaxies down here, I'm not sure which, because like I say, I always get confused by the orientation of these images, but it's probably M110, but I don't really know for sure. Oh gosh, it's so confusing because everything's flipped around, etc. I don't know, might be. Whatever it is. I'll let the astrometry sort it out. That's the beauty of astrometry. You could just pop the image in there and it'll label it for you. It's 4 a.m. or it's 15 minutes from 4 a.m. It's late enough that I've lost all capacity for rational thought, right? So I'm just gonna keep my mouth shut and not screw anything else up. I don't know. That's one of the satellite galaxies down there. Anyway. Power line might pass through in a few minutes, which will make for an interesting sight. Just ambient light from the computer screen will probably illuminate the power line enough that you can actually see it in the picture. Otherwise, it'll be a kind of a dark line that causes diffraction spikes on the stars. It'll probably cause diffraction spikes anyway as it approaches a star, but maybe. Then again, it's so thick. But this is wide field view. I don't know. I don't know how thick it'll look to the wide field telescope. Whatever. It'll look funny. I'll just leave it at that. Then again, it might be pointed above that power line. It might be a while before it hits the next one. I don't know. It's possible within the next few minutes, though. Nope, no sign of power line. Alright folks, well, I think that's going to do it for tonight's webcast. As I mentioned before, I'll post the links to the astrometrically solved images in the video description later, probably later today, or if not, then tomorrow, when I get around to it. I'm hoping I'll at least be able to get the iTelescope links up pretty quick. But these images, the images we took tonight, will take some time to process because I have to individually calibrate every single one of them, astrometrically solve every single one of them, and all that's going to take time. So, but hopefully in the next day or two, I should be able to get that analysis done and post it in the video description. So, thank you all for joining me tonight. I appreciate it. I appreciate all your questions. And clear skies.